Hello, fellow water and wastewater operators. Danielle Morrison, the water trainer here, bringing you my first ever YouTube video. I'm here to help you pass those pesky state certification exams. Please comment here if you have any questions. I really am here to help you succeed. So use this YouTube channel to help you with all the math. We'll get into some lab. We'll get into some process eventually. But right now we're going to start out with some of these difficult to navigate math problems. All right, let's get started. Please be sure to have a calculator and your ABC formula sheet handy because those are the tools that you will have when you're sitting for your exam. You're allowed to have that formula sheet and you're allowed to have that calculator, so you might as well use those while you're practicing. Okay, let's get into it. This is a surface loading rate problem. It comes from an operator here in Connecticut. This appeared on part 2 of the Sacramento wastewater course. So we have a problem here, surface loading rate. The flow rate into a rectangular clarifier is 3 million gallons per day in a tank that is 80 feet long and 25 feet wide. What is the surface loading rate in gallons per square foot of surface area per day? Okay, my first thing, I always set my problems up the same way. I do step 1, what are my knowns? What do I know about this problem? Well, right in the very first sentence, the flow rate. We know flow rate. The flow rate is 3 million gallons per day, 3 MGD. And then we know we have a tank that's 80 feet long and 25 feet wide. I always like to draw, even if it doesn't really help me solve the problem, it just gives me a visual of what's going on. So we know that the width of the tank is 25 feet, and we know the length is 80 feet. Great. What don't we know? Well, we don't know the surface loading rate. So the first thing I'm going to do, surface loading rate, it gives you units. You always want to know what you're solving for. What are you looking for? We're looking for surface loading rate in what units? Gallons per square foot of surface area per day. Per day. So first thing I would do is look at the ABC formula sheet and see if there is a surface loading rate formula. If you look at your ABC formula sheet in alphabetical order, you will notice there is a surface loading rate formula. So there we had step 2. We're going to do step 3 is identify your formula. The formula right from the ABC formula sheet is surface loading rate in GPD per square foot equals flow in gallons per day divided by area in square feet. Well, this is great because we do know we have a flow of 3 MGD. And we don't quite have area yet, but we know from the formula sheet that we can determine area. And how do we determine area? Well, if you consult the formula sheet, we know that area equals length times width. So we can determine the area. So now, if we look at the formula sheet or at the formula one more time, let's just notice that the flow, they want it in GPD. We have it in MGD. So we have to do a conversion. So that's the other thing we need to do in order to solve this problem. So we need a conversion. Convert 3 MGD to GPD. Once we have determined our knowns and our unknowns and our formula, and that we can also determine everything that the formula requires, such as the flow in GPD and the area in feet squared, we're going to begin to solve. So let's solve for all of our unknowns. First thing we're going to do is solve for this area, length times width. So we're going to, as step 4, solve area. Area equals length, which we know is 80 feet, times width, which we know is 25 feet. Use your handy dandy calculator. 80 times 25, and that equals 2,000. 2,000 what? Well, when you multiply feet times feet, you get feet squared, which is the proper unit for area. And you'll also notice, to verify, in your SLR, surface loading rate formula, it wants feet squared, which is what you have here. So now you've got that part, area. So this is going to get plugged in to here when we get there. So we still need the flow in GPD. Now, many people will just do this off the top of their head, but I'm going to do it out. You could skip this if you'd like. Step 5, convert flow. Okay, so we have 3 million gallons, 3 million gallons per day. We're going to use the typical train track method that many of us are accustomed to. Remember that when you do the train track method, your top and bottom, or if you want to consider it like a numerator and denominator, they should be equivalent to 1. Always equivalent to 1, if that makes sense. And you'll see, and I'll remind you as we go. The second thing to keep in mind is that diagonally, you want your units to cancel diagonally. So I'll keep reminding you of that as we go as well, so it'll make more sense. So we start with 3 million gallons per day, and we want to get to gallons per day. So we know if we want to cancel this mg, because we don't want mg, we want g. So let's get mg down here and g up here. Well, what do we know that's like a 1-to-1 ratio? Well, we know that a million with 6 zeros gallons is equivalent to 1 mg. Sometimes that is a little concept that people get tripped up on. When you write out the 1 million Gs, it equals 1 mg. So just remember that. That's a good rule of thumb. So now that we did that, the mg and the mg cancel because everything cancels diagonally. So what does that leave us with? Well, it leaves us with gallons per day. That's exactly what we're looking for. Always consider this line as per. Okay? So now we have the proper units. So now we just have to do the math. So what does this equal? Well, let's go to our calculator. 3 times 1 million, 1, 2, 3, 4, 5, 6, equals 3 gallons per day, 3 million gallons per day. So I know that many of you could just do this in your heads, but for those of us who might not be that quick to do it without visualization, I wanted to show you. So we now have GPD, gallons per day. Remember, the line is like per all the time. So now we have what we need in the numerator, flow in GPD. We also have our area in feet squared. So we've got everything we need to solve this problem now. So let's solve this problem. Step 6. Right from that ABC formula sheet, we are going to solve. Surface loading rate in GPD per foot squared equals flow in GPD divided by area in feet squared. So now we just plug in. Our flow is 3 million gallons per day. And we divide that by our area of 2,000 feet squared. And now that equals whatever the calculator tells us. We already have the 3 million probably left in there. So you 3 million divided by your 2,000 square feet, that gives you 1,500 what? 1,500 what? GPD per foot squared. This is your final answer. Okay, guys, I hope this helped you out. This is not the only way to solve this problem. I do realize that. It is just my method. I like to start with the knowns and unknowns, try to look for a formula, see what kind of conversions we have to make, see what other information we have to ascertain, and then I go right for the formula from the formula sheet. So that is my method. I hope that this method helps you. If you have another way, please share it with us. You definitely don't have to follow along in this manner. If you have any questions, please comment below. I would really appreciate it if you liked my video. And until next time, keep on practicing and keep on studying. You'll get this.